Hello again, and welcome back to our conversation about conic sections. The goal of this video is to take a closer look into an ellipse and its standard form, so eventually we can be able to graph ellipses with much ease. So with that said, this equation here is standard form of an ellipse, specifically where the center is HK, okay, like our friend the circle. But that's about all that remains consistent within this equation comparing to the parabola or the circle. So what else do we need to find in order to be able to graph an ellipse? Okay, let's think about this picture. An ellipse is not only defined by its center, but it's also defined by its two foci. So we're going to need to figure out how to find those. But even if we had the center and the foci, we would also need to figure out where the end vertices lie on the coordinate plane in order to be able to graph this ellipse. Now, we don't need every single point, but I think these 6 points here will give us a good idea of what the shape of this looks like. So with that said, I think the first thing we want to find is the vertices of the ellipse. Now remember this picture, there are actually two different types of vertices. There are vertices that are on the major axis, and there are also two vertices that lie on the minor axis. So I'm going to break vertices into two categories. One is how you'd find the major axis vertices, and the second is how you'd find the minor. The way you would find these vertices is dependent on the equation you have, so let me talk generally for a second. These numbers here, whatever they are, we're just going to call them a squared and b squared because I can't really call it x distance and y distance, and I already have an x and a y. But these are going to tell us the distance from the vertex to our vertices. Now, a squared and b squared don't tell me the distance, but in reality, it's a and b that tell me the distance. In order to answer whether these distances tell me major or minor axis, I would have to know what these numbers were. Okay, the bigger number is obviously going to be further apart, so that would be the major axis, and the smaller number will be closer to the vertices, so that would be the minor axis. So we'll see that in an example. Okay, so a and b are the distance to the vertices. We also need a way to figure out the distance to the foci. If we define the variable c as the distance to the foci, for a minute, then the equation to find c is c squared equals your a squared, which is the denominator here, minus your b squared. Now I should point out, it doesn't matter where your a and b are. A always goes with the major axis and B always goes with the minor axis. So it depends on which one's larger. So you want to subtract the larger one from the smaller one, so you never get a negative number, because we know you can't take the square root of a negative. Okay, we could derive where this equation came from, but it falls into how you derive the standard form of an ellipse, which I link some things on my website for you to look at, but we don't have time to do in this video. So that's how you would find the distance of the foci. Let's look at an example to make this a little bit easier. Say you have this equation here and you want to graph it. Okay, first of all, I'm telling you right now it is an ellipse, but it's not in standard form because it's not set equal to 1. So in order to get this 144 set equal to 1, we'd have to divide by 144. But whatever we do to one side, we have to do to all of the other side. So you're really dividing every piece by 144. So we can go ahead and simplify this fraction. Okay, if we do that, 16 divided by 144, you can divide them both by 16 actually is the biggest factor that goes in, so you'll get x squared over 9. And 36 also goes into 144 36 times, so you'll get y squared over 4, and that's equal to 1. Okay, looking at this equation, our center is 0, 0, and we're going to need to find the distance to the vertices and our foci. So with that said, our major axis this time, let's think about our a and b values. If you take the square root of each of these, the square root of 9 is 3, the square root of 4 is 2. So if you think about graphing this, this tells you the distance from the vertex to those vertices. Okay, so our vertex is at 0, 0, our x value vertex is going to be 3 units away, and our y value is going to be 2 units away. So which one's the major axis and which one's the minor axis? Okay, like I said before, the bigger number is always going to give us our major axis distance, because that 3 is further away than the 2 units is. Okay, so we actually have a stretched out ellipse as opposed to a tall one. So we can find our major vertices and our minor vertices given this picture. Our major axis is the longer axis, so our major vertices would be 3, 0, and negative 3, 0. Okay, since we're just moving from the vertex to these points. Our minor vertices would be 0, 2, and 0, negative 2. Okay, minor because it's shorter, and all you're doing is starting at the vertex and moving either 2 units or 3 units away. Okay, to find the foci then, we need to use our foci equation. So we're calling the distance to the foci c, and we know that c squared equals a squared minus b squared. Okay, now I know in standard form the a squared is under the x, but I just want to reiterate that a squared can also be under the y. It's really just a is the longer distance and b is the shorter distance. Okay, because if you subtracted 4 minus 9, you get a negative number here, and that can't happen if we're going to square root it. Okay, so with that said, we can plug in our a squared and our b squared, which luckily for us, we already know without doing any computation because our original standard form has a squared and b squared in it. So our a squared is our bigger one, it's 9, and our b squared is 4. So that makes c squared 5, and c is the square root of 5, plus or minus. So our foci are plus or minus 5 units either direction on the axis. Now the question is, where do they go? And the answer is that the foci are always on the major axis. Major, and this is always true. So that means in this case, they're going to be on our x-axis. So from 0, 0, we'd move square root of 5 units away, which if you plug in your calculator and get a decimal estimation so you can graph it, it's about 2.24 units away. So 1, 2, it'd be somewhere around here and somewhere around here. Okay, so from 0, 0, our foci are this far away. So that makes this foci point, or focus point, I don't know. That makes this point negative square root of 5, 0. And that makes this point square root of 5, 0. So congratulations, you've just graphed and found all the important information of an ellipse. Okay, now a couple key things that I want to reiterate is that if you look at the equation, you should already know if it's going to be more of a horizontal or a vertical ellipse, or longer in horizontal or vertical. Okay, if the bigger number is under the x, that means it's going to be longer on the x. So bigger number on the x will look like this. If the denominator of the y is bigger, that means you're going further on the y-axis, so it's going to look something like this. Okay, in terms of the foci equation, now I know my standard form that I wrote has a squared under the x, but it doesn't have to be that way. Okay, the a squared is just the distance of the major axis. And b is the distance of the minor axis. Okay, so really, this formula, you can interchange these two. And you don't have to memorize A and B. What I would say is find your A, B, and C, and just go from your vertex and move from there. And this equation was a little bit easier because our vertex is 0, 0. But if you had a vertex over here, you would have just moved 3 one way and 2 the other way from wherever that was. And you can get the ellipse the same way. So with that said, good luck practicing, and we will continue ellipses in the future. Have a good night.